Bismillahirrahmanirrahim. Assalamu alaikum. This is me, Muhammad Ijaz, and my group mate is Shamsul Hadi. Today, that I will present is the optimization of tilt angle for polycrystalline PV module and their performance analysis, a case of Sakkar IBA University. Uh, this is our outline. We will go through first introduction, then problem statement, research objective, literature review, methodology, result and discussions, and in last we will discuss about the conclusion and the future recommendations. So first of all, we have to come to introduction. Electricity is the most significant need for an organization or country to its economical, educational, and social development. More than 1,200 million of people of global population don't have any access to prime energy form. The main cause of the cost and limited natural resources available in the earth crust. Basically, why people do not can't consume the electricity? There are two main reasons. The first is limited natural resources, and the other is earth crusts. Basically, our project focused on the performance of solar PV system installed at Sakkar IBA University. Different sustainable initiatives have been taken by IBA University, like energy conservation, generation form of renewable energy resources, waste material recycling, and initiatives of tree for climate changes issues have been taken in the past by Sakkar IBA University. Green Office Sakkar IB University decided to lowering its greenhouse gas emissions and has broad sustainability standards. By harnessing more natural light and encouraging better air quality, green buildings help to improve the health, comfort, and productivity of their people. We have investigated the performance of solar system installed at Sikar IB University at different tilt angles. Performance of system is analyzed using MATLAB software in the particle swarm optimization (PSO). This is some previous work which has been done by various scholars in this area. First of all, the person is Muslim H.in. He has done his work in 2019. And they study an algorithm based on MATLAB software M-file was suggested to optimize the solar tilt angle in order to increase the PV generation. Monthly and annual ideal tilt angles are proposed for three case studies: Najaf, California, and New Delhi. This proposed approach is a journal program that may be implemented to any location on the planet by adjusting the desired area latitude and longitudes. The other is the Homoi H. Dot. He has work in this area in 2013. Has fixed find various aspects that influence that ideal tilt angle for the maximum solar energy gathering. He suggests a method for computing the appropriate tilt angle based on the daily global sun radiation estimate on horizontal surface. The annual optimal tilt angle is determined to be nearly equal to the location latitude. It was discovered that choosing the yearly average fixed angle results in 8% loss of gather energy when compared to monthly optimal tilt angle. The third scholar is Shafarid M. Dot. He has worked in 2014, has investigated the main obstacle of renewable energy utilizations are unpredictably and high cost of renewable energy technologies. And this regard, integrating renewable energy sources to meet certain areas' energy demand is a possible scenario for overcoming renewable energy problems. Four in the four number is Tibet I. Dot. He has worked in 2014 examines mathematical model employed in this study to determine the solar radiation incident on inclined surfaces and the optimum slope angles for each month, season, and year for solar hybrid collector and derived. It is also noticed that the angle of inclination of PVT collection changes over the year, and that the collector receive more solar energy from the collector without an ideal angle. This is a problem statement. Why we are? What is the problem with tilt angle of the solar PV? Tilt angle is one of the most crucial factors that has a big impact on how much solar radiation a flat surface absorbs. This is one of the most crucial, factor that impact the radiations on the solar. Most effective technique to enhance solar surface slope is using an active sun tracker. We can use solar active trackers which track the direction of sun and rotate over there. But the problem is with this system is can that we can employ this system to a solar 2, 3, 4, 5, but we can't but we can't apply this system to a whole plant of solar consisting of 2000, 3000 plant panels. We can't mm, apply this technique to a big plant. The unpredictable and erratic nature of solar energy continues to other difficulties of PV systems. What are our objectives? Our objectives are maximizing the solar irradiance level on the surface of solar panel to achieve maximum efficiency. Number one. The second, determine the ideal tilt angle for solar system that Sakkar IB University and Saint Pakistan erected. Investigating the influence of tilt angle on performance of photovoltaic system of Sakkar IBA University. Investigating the influence of temperature on performance of photovoltaic system of Sakkar IBA University. And last but not the least, is that improving efficiency as well as fill factor by means of optimal tilt angle. Further, my group mate will continue it, Shamsul Hadi.
So is it just all about aim and objectives? We will try to achieve those aim and objective in methodology part. How we will achieve those aim and objectives in methodology part by first optimizing tilt angle, which can be achieved by numerical analysis. Numerical analysis can be model MATLAB Simulink, and then we will apply optimization technique to find optimized tilt angle, which is Peace algorithm. And finally, we will do some real-time measurements to see the performance of PV module. So these are the numerical analysis where all the equations are used and model them in Simulink. Number first equation is total irradiance, which is the main equation. You can say that where RB and RD are the tilt coefficients to calculate the beam solar radiation and the diffuse solar radiation on tilted surface. RB can be calculated with equation 2, where rho g is the ground reflectance, its value is 0.2. Beta is the optimum tilt angle, which is our desired parameter. And pi is the latitude of Sakkar IBA University, which is 27.7268 north, 68.8191 east. And delta is the declination angle of Earth, can be calculated with equation 3, where n is the number of days in year. In equation 2, omega s is the sunset hour angle, can be calculated with equation 4. Omega s is in equation 2 is the sunrise hour angle, can be calculated with equation 5. Let's proceed further. RD can be calculated with equation 6, where HB is the beam direct radiation and can be calculated with equation 7. In equation 7, H is the global solar radiation at horizontal surface, and the data for H is available on NASA database, where HD is the diffused radiation at horizontal surface, which is applicable at any location with an latitude 40 degree north and 40 degrees south. And HD can be calculated with the equation 8, where KT is the clearness index of atmosphere. KT can be calculated with equation 9, and it is the ratio of H and H naught. H and H naught in equation 9 are global solar radiations on a horizontal surface and monthly average daily extraterrestrial radiation in kilowatt hour per meter square per day, which can be calculated with equation 10. In equation 10, where GSC is the solar constant, which value is 1353 watt per meter square. So this is the MATLAB Simulink flow chart, how our MATLAB Simulink will calculate these things, where GSC, pi, rho g, h and set in value to 1. These are the constants. Then we will try to set beta value to 0 and then calculate all these parameters: delta, omega s is h naught, kt, hb, hd, rb, rd and ht. And then we will increase beta value up to 90. We will see that how much irradiance level on the optimum tilt angle, which will of course the angle which has the most radiations. And then we will see which beta value is receiving more irradiance, and we will terminate our program. So here how PSO algorithm works. First of all, we initiating particles and its position and velocity. Then we calculate fitness of each particle. Then we calculate personal best. We calculate global best, update particle velocity, update particle position. If particle best is greater than global best, then we will terminate the program and we will take that value of beta. If not, we will repeat the same process. So in next slide we will see how this algorithm works, how we initiate swarms. These all are the equations which has been modeled in MATLAB. This algorithm code. We will set swarms to 3 and iteration level up to 50. We will command them the rest of the swarms. Then we will put the horizontal irradiance value, which is NASA database 20 January 20 January, and its value is 4.17. This data can be available on NASA database. Now we are ready. Let's run the code. Code is running. We can see that swarm is converging. Okay, swarm is converging now. Let's see what is the value of beta. Beta value is 61. So it means that 20 January 2022 61 angle is the best angle. Let's increase the swarm size. We initiate 5 swarms, then 70 iteration. Set all the values which we set for 3 swarms, and then run the code again. Code is running. This time it take long time because we initiate 5 swarm and 70 iteration. The video speed is 4x. Now it's converged. Let's see the result. Okay, again the result is 61. So the result is same if we increase the number of swarm. Okay, in real-time measurements, we will see the performance of PV modules to measure irradiance level of PV module, open circuit voltage, short circuit current, temperature of the panels. Irradiance can be measured with irradiance meter. Temperature of the panels can be measured with pyrometer. Open circuit voltage can be measured with digital multimeter, and short circuit voltage can be measured with digital multimeter as well. So these are the hardware design, SolidWorks design. This is the SolidWorks design, and this is the result where we set the panel on 29.5 degree. We have another panel which is on 15 degree, because we will compare what what will happen if we set the panels on 15 degree and 29.5 degree. The reason is we set on 15 degree angle because Saudi Arabia University is using 15 degree angle for their 1 megawatt solar power plant, and 29.5 degree angle is the optimum tilt angle that we achieved from this MATLAB simulating model. This is the results of the MATLAB simulating. These are the radiance level of 15 degree angle for each month, which is 9523 watt, and the radiance level of the irradiance the irradiance level on 29.5 degree angle is 9796, which is more than 15 degree angle, and these are the irradiance level on optimum tilt angle and with respect with corresponding angle. So for whole year 29.41 or 29.5 is the best angle. These are the horizontal surface irradiance available on NASA database. These are the graphical representation of previous table. Black line shows the most irradiance level on the optimum tilt angle. The red line is the irradiance level of 29.5 degree, and the rest of the lines showing the irradiance level of 15 degree and horizontal surface irradiance respectively. We see that the 29.5 degree has irradiance for 7 months, which is more than 15 degree, and 15 degree angle has irradiance level which is based in horizontal surface irradiance. So here we seeing the results of swarms converging. Initially swarms are scattered and they search for best value. The moment when iteration is further proceed, and the swarms is converging towards 59 degree, which is best for 17 January 2022. Here when we increase the number of swarms and iterations, the result is same. Again we have 59 degree angle for 17 January 2022. So this is real-time measurement results. Here we are comparing the radiance of different timing. Radiance on 11 a.m. is more, and then on 2 p.m. radiance is a little bit more than 4 p.m. This is the 15 degree angle and this is 29.5 degree angle. And on 15 degree angle irradiance level is 370 to 85 watt per meter square per day, and on 29.5 degree angle irradiance level is 355 to 898 watt per meter square per day. Now we are comparing power of each panel, 29.5 degree and 15 degree. So we can see that the in figure A, 15 degree angle has a power range between 295 and 315 watt. In figure B, we can see that the power range is between 255 and 322 watt. So we can see that the power is more on 29.5 degree angle. Here we did some temperature versus efficiency comparison. We see in figure A, B and C that there is inverse relationship between temperature and efficiency. At 4 p.m. the relation is somehow direct because the panel surface temperature reduced pretty much. So this is the temperature versus efficiency comparison on 15-degree angle. We can see that there is inverse relationship again. At 4 p.m. the relation is direct because of the temperature is reduced to low level. So to conclude, in this study numerical analysis has been done and then model them MATLAB Simulink. Apply particles from optimization technique to find the optimum tail angle, and then we find for the whole year, which is 29.5 for sucker region, and then perform real-time measurement to see the performance of PV panels. What is the future recommendation of our study? We have applied only one optimization technique, particle sum optimization. It is also recommended to apply few more optimization technique to see what happens. And it is also recommended to install IoT based circuitry system on the panel, which is continuously measure different quantities like open circuit voltage, short circuit voltage, irradiance and temperature of the panels. Due to IoT circuitry system, we will able to deeply analyze the performance of polycrystalline PV module. It is also recommended to check the performance of PV module when panel get more dust on surface. It means when panel get dusted, its power and efficiency reduce. And thank you all the